In this video, we'll talk about a couple more examples of finding lengths of curves using the standard arc length formula. So the first one is to find length of the curve y equals 1/4 x squared minus 1/2 ln x over the interval from 1 to 4e. So, based on our standard formula, this should be calculated by s is the integral from 1 to 4e of just the square root of 1 plus f prime of x squared dx. So let's work out what this is. So f of x is 1/4 x squared minus 1/2 log of x, which means f prime of x is 1/2 x minus 1/2 times 1 over x. Then f prime squared is just normal foiling things out. 1/4 x squared. The cross term is a 1/2 times a 1/2 is a minus 1/2 times 2 for the double on the inner term. And then plus a 1/4 times 1 over x squared. And let's plug that in. So then s should be the integral from 1 to 4e square root of 1 plus 1/4 x squared minus 1/2 plus 1/4 1 over x squared dx. I can simplify some terms inside. That 1/2 can cancel to make a plus 1/2. So 1/4 x squared plus 1/2 plus 1/4 1 over x squared. Now I want to figure out how to handle this expression in here. This is a little bit of a trick you can look for in here. And the point is that inside is a perfect square. How do we figure that out? Well, there's a couple ways to think about it. The first and easiest one might be to sort of move a 1 over x squared out of the square root. So if I do that, I get integral from 1 to 4e of a 1 over x outside the square root. So x squared inside is an x outside. Square root of now a 1/4 x to the 4th plus a 1/2 x squared plus a 1/4. I'll also move a 1/4 out from inside the square root to make it a 1/2 outside, giving me a 1 to 4e 1 over 2x square root of now x to the 4th plus 2x squared plus 1. Now that should be sort of obvious what that thing inside is now. It's x squared plus 1 all squared. What does that mean? It means that squared and the square root cancel out, and this becomes an integral from 1 to 4e of x squared plus 1 over 2x dx, which is integral from 1 to 4e of 1/2 x plus 1 over 2x dx. I can now do that integral. That's an easy one to work out. And I get that this is x squared over 4 plus 1/2 log of x from 1 to 4e, and I just plug in my endpoints. So that's 16e squared over 4 plus 1/2 log of 4e minus 1/4 plus 0, because log of 1 is 0. Log of 4e is log of 4 plus log of e, and log of e is 1. So I will get here a 4e squared plus a 1/2 log of 4 plus a 1/2 minus a 1/4, which means my final answer here is 4e squared plus 1/2 log of 4 plus 1/4. So the key trick there is recognizing the inside bit as a perfect square, so then you can simplify it out and actually get something you can integrate. Our second example here is the following. Find the arc length of the curve y equals 1 over x on the interval from 2 to 4. Again, we know the formula, we can just set it up. Here we have f of x is 1 over x. So f prime is negative 1 over x squared, which if I square gives me a 1 over x to the 4th. Meaning my formula here is s is the integral from 2 to 4 of square root of 1 plus 1 over x to the 4th dx. And this here's a case where we have nothing we can do to solve this problem, right? There's no nice technique, no nice approaches, nothing that we actually know that will help us figure out what this integral is. So we're stuck here resulting in numerical methods. You could try to move the x to the 4th around, becomes an x squared on the outside, but there's not really anything that's going to actually get you an answer here. Trig sub's not going to help, nothing's really going to work out here. So we're stuck here resulting in numerical methods because we don't really have a way to solve this. You have to do some sort of Simpson's rule or a really good midpoint approximation, something like that, to get this answer. And you could get that s is approximately equal to 2.018. That's the other point here, is that sometimes these integrals are not solvable by hand, and you'll need to use numerical approximations to get the value of the integral. These ones you won't see on exams because you can't do these ones on exams, but it's important to know these ones are out there, so if you see problems in the future you feel like need this sort of calculation that you can't solve, it's a possibility that there actually is not a way to solve this directly. You have to use a numerical approximation to do so. There's more examples of using the arc length formula to find lengths of curves, one you can do by hand, and one that you can't, and you would need a numerical approximation to figure out what the answer actually was.